Hello, welcome to the Sensors Unlimited United Technologies Aerospace Corporation booth at Photonics West. We're having a very successful show. Been quite busy talking about our new products. One of the first products I want to discuss right now is our InGaAs linear arrays. We're relaunching them this year. Last year we moved our fab. We've qualified our production processes, our sources of supply, and we've been able to drive down dark current and linear arrays, which is an area that even industry-wide hasn't received much attention for a while. The improvements we've done to area cameras have now been rolled into our linear array line. And so we are also introducing a full range of wavelength cutoffs. You see in this chart, our quantum efficiency chart, room temperature as nominal temperature. We have a light orange curve that cuts off at 1.45 wavelength. This has been introduced particularly for the handheld Raman market, where for the Raman with a 1064 laser, you don't need much response after 1400 nanometers. By cutting that off, we drastically reduce the dark current supporting handheld applications. Our standard curve is the redder curve here, cuts off at 1.7, standard lattice match InGaAs. This has again benefited by reduced dark current, better uniformity, better contacts, improving the product. In addition, our 2.2 and 2.6 versions, where the dark current's much higher, we'll talk about in a minute, have also benefited, now have a regular source of supply. During our move, we had some disruptions. We have improved our delivery now, very consistent. So these are the physical manifestations of the linear array product in this box. You see the devices without the normal window lids, so you can see the inside. Kovar hermetically sealed packages, silicon readouts with InGaAs detection in the middle. And we offer a variety of formats depending on customer need, number of pixels, and resolution. If we shift down a little bit lower, we've got a summary chart which is on the sales sheet that's now on our web. And what I want to call your attention to here is for the different cutoff wavelengths. I'm showing the dark current, give you a sense of the difference between the 1.45 and 2.2, about a factor of 2 improvement in dark current when you go to the shorter wavelength cutoff. You go to 2.2, you have a dramatic increase in dark current. This does limit the exposure time you can do at room temperature, but these are available with 1, 2, or 3 stage coolers, allowing you to run the focal plane much cooler temperature and drop this dark current down to more manageable numbers. But this gives you a little bit of the relationship between the different products. So continuing on another segment of our booth, I want to talk about our new 12.5 micron pixel cameras, the 320 by 256, an example of which is shown here with the very small focal plane, 4 millimeters by 3.2 millimeters. We're introducing this at a very affordable price point for the market, who've been anxious for a much more cost-effective solution for things like laser beam profile, other applications, even some hyperspectral imaging. We also have the same package and form factor with standardized connectors, shrink ribbon connectors for our 640 by 512, which will have 4 times the collection area. These cameras, the news on these cameras is that both the 320 and the 640 are now under the Department of Commerce jurisdiction for export licensing control. This means for the 38 common countries, direct export under STA exemption makes it far easier to send these cameras out directly, or for our OEM customers to incorporate them in their products for inclusion and resale without restrictive, burdensome regulation documentation. So a major shift in government policy for a camera with a very low read noise of 30 electrons RMS noise floor. So now we'll talk about some of the other elements of the booth. So now I'd like to point out some of the standard products in the booth. Our 1024 machine vision camera, the LDM. Next to it is our 2048 L and R cameras, particularly for OCT, spectral domain OCT. Then the most sensitive camera in current production for low-level light imaging in the SWIR is our 640 HSX camera, and followed by the 1280 JSX camera. That camera we have under this active display in the booth, where this monitor is showing the high resolution image, a high definition image from that camera looking at the show floor. So thanks again for your time and attention to our presentation. Please contact us at Princeton, New Jersey via our website, www.sensorsinc.com, for more information or quotes. Thank you again, take care, have a good day.